Hey, so this is Esteban and Lucas here for ER and R's final design review presentation.
Part two. The first one took 20 minutes, so we're doing it again.
Yeah, I had to cut it down.
Uh, let's
Go
go.
ahead. Next slide. So this is just a quick overview of the Gantt chart. On the left-hand side, you have what is mostly the head unit. So the instrumentation, the pulse width, the low-pass filter, and then the construction and design of the PCB. On the bottom of that, there is the alpha and beta filter, and then on the left, it's the finishing up of the base unit and all of the total device and report. As you see, there's only one object here that's not entirely completed, and that's the transferring the base unit to a perforated board. But we'll go into that in a little bit more detail in just a minute. So here's the complete entire circuit. Over here on the top, we have the reference voltage generator, and we have two of those, one for the head unit, one for the base unit, such that the two different devices are each powered by their own 9-volt battery. And yeah, so you'll see the voltage go in to the instrumentation amplifier through the filter, where it goes to a comparator with the triangle wave generator, and that pulse width modulated signal then drives the LED emitter. It's then transferred over a distance of about a foot to the receiver, where it is then separated and filtered into the alpha and beta waves, and each of those separated signals drives their own LED. This is just a couple of update pictures, each of them labeled with which week it was, and just showing the construction of the circuit. And then here we have the populated head unit and baseboard with a couple of labels, so you can see where the positive and negative battery terminals would go. And then on the left-hand side of the head unit, we have the positive and negative electrode terminals. So those were then outputted so we can attach the terminals to our forehead. On the right-hand side, you have an image of the baseboard that we ended up using. This picture is a little bit outdated just because we did make another change to the way the drivers were set up. But it shows you the alpha and beta bandpass filters and the IR receiver. In the full project report, there is an up-to-date picture of the baseboard that is used.
Okay. So let me just stop sharing for a moment and talk about the demo part real quick, especially the enclosures. Here's one of them. Here's another one. You might be thinking, what the hell are they doing with that kind of enclosure? That will be explained in the final report to save on time now. But anyways, just to demonstrate some things, if we can do this in an easier way. Here is the base unit. Here's the head unit. Just to make it easy, we'll just show the connection between these two. They are movement will turn on both LEDs. As you can see, we have alpha and beta. The connection's about 10 inches at most when you get it right, but you can see the LEDs turning on. The issue is that you might be wondering is, why am I not wearing this on my head? Actually, just showing the system working as intended with the electrodes placed reading EEG waves. Well, in that instance, one of the reasons was just because the way the emitter and the emitter and the receiver are set up, it's been hard to actually wear on my head and then to take a look at it, which is a design issue for the enclosure. So my fault. I should have been more careful on where this base unit would be placed in reference to my head. But the other issue is that the other two issues is that one, this enclosure is so big because we're not using this. And that's also a reason explained in our report. This became, due to multiple reasons, too time consuming and too difficult on my end. I kept on making errors that proving for me too difficult to fix, too time consuming, that even though it's close to complete, I just decided to cut our losses and to use the protoboard unit that we knew would work, as we already proven in other weeks. That's, I'll explain in the final report. The other reason is the head unit is not working as intended. In our previous, or you won't see this, but we spent like 15 minutes unknowingly talking about why this isn't working as intended. And I was bumbling and rambling on throughout the entire process. For the most part, for one thing, it's really well explained in the report what we've concluded had gone on to cause issues with the head unit. But just to simplify what occurred is that through a whole lot of testing, the IR pathway works, the PWM pulse width modulator works pretty much as intended. All the voltages, most of the voltages were correct. Everything was supplied. Triangle wave, we saw measured a triangle wave there using multimeter, kind of just listening to it. We even saw that for the instrumentation amplifier, we saw that, normally the output is V reference, about in this case, about 4 volts, that when we put electrodes to my head, that had given a signal that went to about 5 and 3 volts, so about 100 millivolts, which means we were getting a signal in the expected range. However, the issue was that the pulse width modulator was always high, and that was evidently concluded because the output of the bandpass filter, the EEG signal was being centered at around ground, and therefore always lower than the triangle wave, and always getting 100% duty cycle. We concluded that something was pulling one of these nodes to ground, presumably the inverting input, because it's lower than even the non-inverting input. And we hypothesized that it was probably these large bottom layer ground paths that were causing an issue. This through hole is the closest to a trace anywhere else on the board, and that might have been a problem. We went over it, soldered, resoldered everything. I really scrutinized and make sure everything was placed correctly, all the components were good, and I didn't find any physical issues except for the fact that we concluded that something was pulling the signal to ground instead of keeping it on V reference. And and I hadn't had time or the ability to fix it by the time this presentation occurs. But just an interesting time of our presentation, I just refer you to the final report. That's where everything's going to be explained in really great detail, I believe. I think we did a really good job on the report. So that should answer all the issues that you've seen presented really quickly in this presentation, because we're just trying to cut it down from 20 minutes as we've previously done and not shown you, to about 10 minutes. And it's, I figured that it was also, to end it off, I figured that it was hard to demonstrate some of these voltages being read through the multimeter on this demo presentation. So if there's any possible time when you're grading and you're saying you want me to prove these measurements or anything like that, go ahead and email us and we can do that for you. We're okay with trying to work on this even still after doing the grading period, because we just wanted to show you that even with this board not completed, and that the head unit's not working to where we can't even prove that there's EEG signals at the base unit, we've concluded that, and I believe it's true, that our head unit's 95% operational. The base unit works as intended, and so go ahead and read the report. If there's any questions, just ask us. We really want to make sure that this doesn't come off as a totally incomplete system. So
Yeah, we were able to properly isolate that the bandpass filter and this mysterious ground connection is almost certainly the main source of error in our system here. Um, but thank you again, Professor, for your time. And if you have any questions,
thank you.
just let us know.
All right, let's go ahead and end the presentation. So